Hello. Well, should I begin? Yeah, let's start with me first, because this is me. Well, at least that's a logo I use. I do something with CocoaHeads. I work at some insurance company. Does anybody have any questions about me?
Why?
Why what?
We have to.
Why? Yeah, why do I exist? Yes, 42. Something I wanted to mention. On March 16 and 17, I'm organizing a test-driven development workshop with John Reed. He writes a book on iOS unit testing at the Pragmatic Programmers, pragprog.com. More information on that on the bottom URL, or come talk to me. So this ends my sales pitch. So what I'll talk about, at least this is going to be the gist of my presentation. Usually, it's the end of the day. It's time to go home. You're thinking about what should I do tonight? What horrible television should I watch or not? Maybe some Netflix. So you push to master, and you're done, right? At least that's what I would want to have. You know, like just push it and be done, because then we can drink beers or water or whatever floats your boat. Any questions so far?
How many beers? You have the 42. This is labeled.
Which say? Oh, it's
you better show it every 5 times.
this one, you mean?
Well,
It's going to be back only once, but then on that slide there will be 2, like 4 beers, and that's about the amount you were asking. Because if I drink more, then the next day will be bad. Because not this size not this size. Because if it would be this size, then it'd probably be 1, and with 2, I'll be like, yeah. Maybe they have midget beer. Well, of course, when you push your code, there are some steps involved, and I'm talking specifically about iOS app development, because that's what I do. I guess most of you do that as well. So after you push the code, you actually, or something needs to check out the code, compile it, archive it, code sign it, and then upload it to Apple. And that's where Github Actions comes in my presentation, at least, because there's, of course, other options out there, because who doesn't hate Jenkins? Or you have like BuildBot, which was acquired, Circle CI. I think they're going to be acquired pretty soon as well. You have Azure DevOps. Anybody tried that? It's actually quite good. Yeah, and of course you have, well, what other options do you have? Yeah, because so pretty much everybody in this room has done some sort of building or continuous integration on their code base. So apparently it's something we either have to do or it's something that we like to do. But GitHub Actions, that's the offering that GitHub offers their community. But pretty much you can run a workflow on any GitHub event, and GitHub can present you with a lot of events if you want to. Your runtime environment can be any of those, so Linux and macOS, those are, for me, are the most important ones. Live logs pretty much means that if something's running, you can see the logging, and you can look at it and just, I don't know, maybe it's more exciting than goede tijden, slechte tijden. It has a built-in secret store, and it is free or cheap. It depends a bit on what kind of project you're running. And cheap does not mean cheap as in China cheap. It means that it's cheap as in you get a lot of bang for your buck. So the thing that you need to understand is that the hosted runners that GitHub uses are actually full-blown macOS environments. So it's a macOS installation that runs virtually, and it's a pristine environment with some tools installed, which is of course required if you want to run Xcode build. And something that I noticed is that the GitHub Actions and the Azure DevOps pipelines actually share the same pedigree. It's kind of obvious because GitHub came with GitHub Actions like sometime after they were acquired by Microsoft. Hey, thank you, Microsoft. And I must say that I actually kind of like Microsoft nowadays. Not the Windows platform, but the other things that they do. So your workflows are defined in YAML files. I don't know why they chose that format, but well, once you've written it, it's pretty readable. Don't mess up with your tabs. Make sure you use an editor that annihilates any tab characters that you either copy paste or type yourself, because it will be an instant failure on your build. But you define them in this directory. This is at the root path. This is a root path within your repository. So something, file name, and then YAML. So pretty much, this is the simplest example I could come up with. The name at the top, I copy-pasted it from somewhere. But what this does is it just dumps the file hierarchy of the home directory of the runner. So if you push on master, that is. Any questions on this so far?
Dumps it where?
Yeah, well, it just presents a listing of the file hierarchy in the log output of the runner execution.
What means my macOS label? Does it include also Xcode or not?
Yes, I can show you that in my demo, because the runs on is actually a definition of a defined set of runtime environments that you can choose to actually execute your runner on. And it can actually also be something that you host yourself, but then you have to run some service tooling provided by GitHub, so then you have a self-hosted runner. But that's if you want to do like really unique or sensitive or special things that are not easily facilitated within the standard runners available by GitHub. Of course, this triggers on pushes to master. This triggers on pushes to pull request branches that have master as a target. So you have to have a branch, you have to push on it, and on that branch you have to have a pull request defined towards master. So this is very convenient if you have an open source project and you want to allow other parties to request introduction of their code into your repository. If they present you with a pull request into your master branch, then it will be executed and run on your scripting. But your secrets, they will not be shared with this execution. Of course, you see steps here. Those are your building blocks. So as you remember, we need to do 3 things: check out the code, that whole bunch, and then upload to Apple. Checking it out is quite simple. Just this. This is one step, which just executes and then clones your repository and makes sure that that it's at the head of the branch that you have defined where it should trigger on. And then there's this. Well, this should be standard stuff, right? Any questions? What you see here is 4 things. Is it legible in the back of the room? What you see here is 4 things. The first one, that's over here, the top one, that's select Xcode. That's how you can select which Xcode you want to actually use, so which tool train you want to use, because on one of these macOS latest hosted runners, you have I think it's about 7 or 8 different Xcode versions available that you can actually choose from to run your code with. And Xcode 11.3.1 will be available in 2 or 3 days from now. For convenience, I dumped the Xcode version so that in my log file I can at least see easily what specific and exact version of Xcode I have been running against. Then there's an Xcode build command. And pretty much everything that's in there, what it leads to is if you in the Xcode menu press archive, then you have to have the proper scheme selected and some other parameters need to be correct. But then you will be presented with an archive in this archive window, and this command does the same thing. So you say what SDK should it run against. It could be a simulator as well or macOS. Then you say which project. You can also select a workspace, of course. And then I want to have a release configuration for my CocoaHeadsNL scheme, and I'll output all my derived data to be dumped in the derived data path. It's convenient to do that because otherwise it's like deep down there in one of those developer derived data paths with like this nice UUID in there. So try finding that when you're looking through a straw, because that's one of the drawbacks of using a runner like this. And I provide an archive path where I want my archive to be output. Then I export the archive, and that's the same thing that you can do within Xcode. It's selecting the archive and then right-clicking, or what is the button on the right, and then you say that you want to export it, and then you have to provide a few options. You have to select which provisioning profiles, you have to select some other things, and you provide that within the export options plist. And of course, I will provide a path where it needs to be dumped, because I want to be able to find this exported EPUB file later. And then there's the fifth step, and that's the deploy to Apple. Who's actually ever done this from the command line? Did you notice that it...
Fastlane does it.
Well, Fastlane somewhat used it as well. Because I don't like Fastlane for these kinds of things because it's this magic toolbox that works if it works, and if it fails, you can never figure out what's wrong. But basically what this does is the same thing as the, what's it called nowadays? The application loader, or is that now obsolete? Well, there was this tool available that was the application loader, which was the transporter. It was a Java file program, right? Yes, it was. This is actually a Java-based tool as well. But what I've noticed, if I run this tool compared to any of the other options that Apple has available for uploading your archive, I don't know why, but it is way faster than anything else. But basically, what you do here is quite simple. You just upload your app to Apple. So once you've done this, after processing, it will be available to App Store Connect users for immediate installation through test flight, or you first need to put it into test flight review or App Store review to make sure that it becomes available. So now we can push to master and be done. What do you think?
He doesn't need tests.
No,
I'm 10 times programmer.
No, you can run unit tests. That's just a matter of putting test before the archive in the Xcode build command. On the actual sample code that will be available, that is actually available on the CocoaHeadsNL repository, that's actually being done. But nope, we cannot. We're not done yet. So, because of course we all know provisioning, right? Or at least we've heard of provisioning, or we've dealt with provisioning, or we cursed provisioning, or. But of course, provisioning also means you have to have some sort of code signing certificate. And in my case, I want to have the distribution certificate because I want to upload to the App Store. But of course, these are like secrets, so you have to think about security. Because if any old fool gets a hand on these things, they can sign any binary as if it were from you. Remember the secret store? This is a nice helpful link that explains a lot on how you can actually do this. First, some assumptions. You have to do manual code signing for at least your release target. I prefer using automatic code signing for my developer workflow, but for release I prefer manual because it just gives me a little bit more control. And control I want on my release builds, and on developer builds I just want it to work. And usually automatic signing does that for me. And also you have to trust Github Actions enough to host your secrets. So that pretty much means your distribution certificate and your app-specific password that you use for this AL tool execution to upload your binary actually. So those are two assumptions, and if you can't agree with this, then pretty much any cloud offering out there you cannot use. Manual code signing, of course, we know, just make sure that that checkbox is off, and then that the other options are like correct, and that you connect. And basically maybe try building a release build on a device. Might prove that it doesn't work yet, need to do some more tweaking, but this checkbox is the most important part. So the secret store. Well, actually this CBM is actually, it's now Airbnb that you see in the background. But the secret store, it allows storing string-based data of about maximum 64 kilobytes, because who needs more than 64 kilobytes, right? The other option is to store your information encrypted with a key that you store with GitHub. So then actually you put your key within this secret store, and then you use that during your execution to actually decrypt some stuff. Well, it is of course some cloud offering, so I wouldn't put my login credentials of my bank accounts there, but I'm okay with these credentials. For the rest, it is recommended that the user that actually does the uploading, that you try and restrict that user on App Store Connect in some way, so that at least that person that credential cannot put an app live. So I chose to trust GitHub to some degree. So you can store a base64 encoded file as a string, because it has to be a string. But you can also store a key and use that key to encrypt the file. I did the second thing. Here's the documentation that I linked before, but this is not a specific link for creating and using encrypted secrets. If you use this documentation, it won't work, because there's one single catch that for some reason GitHub has forgotten about, and that's currently GPG is missing on macOS hosted runners. But fortunately, it's easy to fix with the Brew install. Brew is one of the standard tools that is available on a macOS hosted runner. So add this, you have GPG. That adds about 20 seconds to your build time. So the rundown with secrets, you encrypt your files with GPG, you add the files to the repo, the encrypted files of course, and you decrypt your files in your workflow. The password you store as a GitHub secret. This is how you could decrypt files. Whoa, wait a minute. That's a shell script. Well, why would I put it in a shell script? Basically, it hides the command line that actually contains the secret. Because if you would put the command right here, then the provisioning password would be passed through there. It won't be visible. But if you what's it? It's not globbing, but it's, I forgot the bash word for that. Yeah, if you put the password within your command line, like right then and there, it would be visible in your log output, and pretty much you don't want that, because then your password would be stored somewhere just visible. Especially if you're an open source project, anybody can read those logs. So why a script? It hides the command line containing the secret. So the steps will be decrypting the files, installing the provisioning profiles, and installing the distribution certificate and key. Especially that third bullet, that's the fun one. That took the most time. So decrypting, just the GPG command line. You can look it up online, just a lot of parameters. The important one is the --batch command, because that basically just types yes on any question that GPG normally would provide you. Because otherwise your process would hang, waiting for input. And this just says GPG, says yes, 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 and then it's encrypted. Yes. So the output is of course the P12 file. Make sure that you export your distribution certificate as a P12 file from Keychain Access. Make sure you do that from the. You have to make sure that you both select the private key and the certificate, because otherwise you have like a broken P12 file. If you run into issues, just ping me on Slack and I will help you, because it's one of those. Once you've done it once, you know every time it fails on you, you know what the problem is. So it takes the GPG file and turns it back into the P12 file, which of course has a password as well. And I do the same thing with my provisioning profiles. They're not too important to encrypt, I'd say, but well, it's good practice anyway.
Can I ask a question, or you want to? Yeah.
No, just ask away.
This GPG command, is shown up in your process list with your provisioning password.
No, it's in the bash script. This is the contents of the script. As you see, there's like there's a hash bang at the top. It's a shell script that you execute.
Yeah, but then the GPG is visible in your process file, which is executing.
And
Standard Unix.
yeah, but the command now these executions, they're not visible in the log file of GitHub. So
Oh, okay.
I will show that later because I understand your concern. And the way the CocoaHeadsNL app is set up, it needs 3 more provisioning profiles because it had some extensions. But those are pretty much the same commands, so for brevity, I didn't show those. Installing the provisioning profiles, if you double-click and download the provisioning profile, magic happens, Xcode opens, and wow. But this is all it does, people. Nothing more happens if you install a provisioning profile. It's not more complicated than this. You have some mobile provisioning file somewhere. It copies it into this library mobile device provisioning profiles. Then it's done. Then it's available to Xcode. You can use it when you're code signing your app bundle. And just for debugging, I list my profiles before and after this step so that I can, at least in the logging, see that yes, it actually copied something there, and yes, there was nothing there before. Yeah. Do I really need to go into this? This is pretty much how you can add your P12 file to the keychain and make sure that the keychain itself is not locked. Look it up online. I don't know, especially this last command. I copy-pasted it from somewhere. Somebody said this is what you should do. But from what I understand, it basically it takes the system key or the user keychain and attaches another keychain to that, and that keychain that is attached actually contains your secrets, and it is actually unlocked with a blank password. That's the -p double quote there that you see. It creates it and it unlocks it. And this set partition list makes sure that it's like available within your user's keychain, because of course it's a Unix-like system, so there's actually a user running all the processes. It's also the place for usernames and passwords that you require for uploading to Apple. Also, if you have some kind of API key that you don't want to share with the world, but hey, you bundle it in your app, so it's not a secret. But if there's something that you don't want to have in your source code, but needs to be available when you compile it and is somewhat secret, you should add it to the secrets store as well. So, demo. So, GitHub Actions. We have two actions, or actually workflows defined, CI and deploy. CI is actually what runs on pull requests, and deploy is what runs when we actually merge or push to master. Now for the contents. Oh boy, yeah. Presentation light. Large light.
That's very large.
Too large? And for some reason my mouse pointer is really sluggish. It's probably because I have this thing attached. No, there's a big delay between that screen and my input, so I should look here. So, let's see. Now it puts it back to that. Seriously? Then I'll go with dark mode anyway. So, so this is the CI script. Basically, if you push to master, or if you have a pull request towards master, we want this to run. We love SwiftLint. Who likes SwiftLint? Does it slow down your compile as well? Yes. Yes. We'll talk later, but you should make sure that if you have a somewhat larger project, to make sure that you actually use the input and output list feature of run scripts, because it will drastically reduce the amount of recompiles that you have to deal with. Because I work on a project, if you do a fresh compile, it takes about 5 minutes. It's not too bad. So yeah, SwiftLint. The fun part is I use some third-party dudes stuff, and well, the nice thing is that if SwiftLint actually has any findings, it will, due to how this plugin is set up, it will show up as annotations on my pull request, which is nice because then you don't have to do it manually.
Last question, sorry to interrupt. Why would you need SwiftLint in the pipeline?
Because there's always, there's always people who ignore warnings in their Xcode environments, and those are people you need to slap with a trout. But it's always more convenient if you automate that process.
The slapping part.
The slapping part, yes. So we run a test, and actually what's fun to see is I chose to use Ubuntu here because it's just Ruby code and it's just files, and the Ubuntu they have a lot more runners available of those. So this actually makes sure that my entire build is actually done quicker. So the checkout, all the Xcode versions, then I run it. Somebody said something about unit tests. We can do those as well. XCPretty is installed by default. Run it on a simulator, of course, because there's no devices attached as there is on App Center, for example. And that's pretty much it. This is all I need to do to make sure that everything is Swift-linted and that my unit tests are run. Actually, that my XC tests are run, because if I would have UI tests, those would be run as well on a simulator, and that's possible on Github Actions. And then the deploy YAML, that's pretty much the same, except of course the brew install GNU-PG, all the Xcode versions, decrypt large secret. You have to make it sound NSA, right? And we select the Xcode, we build the archive. I don't do unit testing here because that's because my CI workflow also runs when this flow is ran, because it has the same parameters. Well, I should say that correctly. This runs on push to master, and the CI one, it runs on push to master and on pull requests. So I don't need to repeat myself, right? And I dump the file hierarchy, which is very convenient if you try and find your files and want to know your input for the next step. And this pretty much uploads it to Apple. So how does this look? You have these are my CI runs. This is just a listing of what has run. You have a setup job. You get the checkout, for example, because this is output most people have seen in their life. You see, it's a standard clone. There's you can do a lot of scrolling here if you like doing that. For SwiftLint, there's the action. It just runs. It's the regular output that you would expect from your command line. So there are some violations in there. Oh no. I should probably slap myself. And then the job is is finished, and it cleans it up. GitHub states that that they use like a layered file system because all these runners are actually Docker containers. But if you prefer deleting your files yourself, for instance, especially the security-related stuff, by all means do so before you, as one of the last steps in your build. But if your build fails out, those steps will not be run, of course. How does this look in practice? Of course, we have a dummy pull request. This is the start for the fix of 51, Bruno. This is an issue that you raised. So this is your cue to start finishing this. And then you have the checks here. It's a sort of a look into your actions. Can open this up and look into it, but it looks pretty much the same as what I've just shown. But the file changes. That's of course the interesting bit, because this is the actual change. But SwiftLint has some complaining to do, and you actually, but you now get this. So yeah, it doesn't agree with this this identifier name. Well, I can agree to that. Type name violation. Type name should be, wow, 40 characters. Woof. And yeah, of course, these are all very much things that we still need to do. But as you can see, this really adds on your workflow and the visibility of actual problems within your pull request. You can also include danger as a dependency on your build. I just didn't get to that yet. And I don't think Bart would agree to that as well, because then he would get so much email. Yes, but then you would have to error out, because if you have a script error, it actually aborts the build. So you could actually treat Swift warnings as an error. I haven't seen if there's like I think if you have SwiftLint report violations as errors, then it depends a bit. Yeah, you can actually make sure that the check doesn't turn green, because if you look at a conversation, yeah, then one of these checks would then actually turn red. And I think in the project settings you would have to toggle an option there that checks have to pass before merge is available.
You don't know if GitHub has a warnings as errors.
Well, if there's an error, then the check has not passed.
Oh, that predicts it.
And I think, wow, I always, Yeah, is it actions or is it enable local? Okay, this is all the runners, but it would be somewhere in the settings.
Branches?
That could be. Yeah, you have to add a branch protection rule, and then you would be able to do that. Yeah.
Do it live.
Hmm?
Do it live.
No, let's not do that.
It's not Friday, so you can do it.
Yeah, but I want to sleep tonight. So yeah, that was my demo. Oh, one more thing. That's a bit... Seriously? I have to exit it. Where's my terminal? Let's see. Because I know what I'm doing, so I can push to master, right? So this just pushes it. And then if I go back to my repository, if I just look at my actions, you see that it is that deploy is running and CI is running. So if you are Bart, there will be a new build coming in like 20 minutes. Good. Oh yeah, I was busy, right? So now can we push to master and be done? Yes. Yeah, you like a clean screen, right? You're one of those, I polish my screen every week people. So now we can drink beers. Oh yeah, one more thing, or well, a second thing. Of course, you can run unit tests, as I've shown. You can run SwiftLint and annotate those linting violations pull requests, as you've seen. But of course, it's just a standard Unix environment, or well, Unix-like environment, whatever you use as a runner. But you can do all kinds of things. I wouldn't run a crypto miner there. Questions?
Thanks. Yeah, I've seen first, thanks, was really nice. I've seen quite a bit of scripting / bash commands. Is that stuff that you have to figure out yourself, or does GitHub have like templates for that?
Well, of course, there are some details that you need to figure out on your own, so for especially the Xcode build commands. But the documentation that GitHub provides on Actions is quite extensive, and it is growing every day. And also the amount of uptake by different open source projects is quite good. So there's a lot of samples out there that you can find. And as you've seen, Once you know what you need to do, the actual YAML file is quite straightforward. So there's not much you need to add, but it's indeed true you need to know what you need to add. There are it's not plugins, but there are custom actions available, like the SwiftLint one that I showed. And those are also ways to get packaged pieces of functionality.
Yeah, you can call your own scripts.
Yeah, you can call your own script. You just add it to your repository, and then, or you can drag it from a network site somewhere. But yes, you can just write your own script and execute those. Make sure to cmod those.
Cool, thanks.
Thank you. Hello.
Hey.
Thank you for a speech. I have a question. Do you know anything about like complex dependencies when you have, for instance, a project that have different dependencies, internal one? So, and you change one dependency and you wanted to push a master and you wanted to run unit tests only for this dependency and for project itself, not unit testing for every sub-project. So is it possible to do with GitHub Actions? Because for Jenkins it's possible.
Yeah, but with Jenkins, is it like some out-of-the-box functionality, or do you need to script it somewhere?
It's like you change this folder, then you need to run tests for this framework, kind of with workaround.
Yeah, well, you could script if you would do it with Xcode build command, you could do that, because with Xcode build you can add on your test command, you can actually add an argument of which tests you want to be included or excluded from your run. So you could do it that way, but then you will need to have some inventory of all your tests and which tests are attached to which pieces of your code. So it would be possible, but you would need to do some scripting. And if you want to have interdependencies between different builds, you could look into what GitHub calls matrix builds. But I do know that if you use Azure DevOps, then you can really do like separate steps and dependencies between your jobs, actually. So you can have like 4 jobs that need to be completed before some other job can actually start, for example. And Azure DevOps is also available open source if you want to. So
Okay, thank you.
Thank you. So I'm surprised you don't have kind of after script, but okay. So question is, so I saw that the log file is shared or recorded by default, and you can see it. But can you share artifacts, screenshots, whatever? So do you need to use some storage where you push, or it's something built by default?
Everything that is stored on the runtime environment is temporary, so it's ephemeral. So it will be wiped once your runner has been deallocated. So if you want to store something, you would need to offload it to some third area. So either you need to commit it to some repository or dump it in an S3 bucket or something like that. But that you could do that, and then you would have to add those secrets to your secret store as well. But it is not something that GitHub provides out of the box. Azure DevOps, on the other hand, does have an artifact area that you can store items like this with a simple extra line.
Okay, thank you.
Any other questions? Last one? Because I really want my beer. Okay, thank you.